All right, I think we have started the recording. So welcome guys, it's session number 7. Thank you everyone for coming. Just since we're getting started, I'll just spend a couple of minutes on this one. I'm hoping that you guys are getting something, at least some satisfaction out of this discussion. Remember, it was our requirement that the session be self-paced. There's no real goal as such here that we have to be able to complete this in, let's say, 10 sessions. I mean, it is about exploration. But the idea of your thinking and to light your inner fire so that you can discover at least some of what we discussed. Find difficult to catch. We can't just be confident that I have found something on a time, right? It's always elusive. But I'm hoping that you guys think that this is fun, just so that, we all feel good. Can we raise our hands or give me thumbs up if that is the case? If that is not the case, that's also fine. But I just want you guys to tell me that you guys are having fun. Thank you very much for the encouragement. I think, you might think that this is not a big deal. No, I mean, I want to reiterate that this is a big deal, having some kind of a fun with what we're doing here is really important for all of us. So I will quickly recap what we have done so far in like 1 minute. And we have now started to understand the kind of mysterious feeling we get when we think of infinity. Like the concept of time, the concept of infinity is elusive. You think that you understand it, but you may be presented with something, some paradox or, some thought experiment that makes you think again. And we looked at paradoxical situations, of course, right? I think, my favorite one is, okay, does this line have more points or the circle? We also looked at infinite sets a little bit. We haven't yet looked at one of the most interesting infinities, the infinity of the real numbers, and we'll get to that soon. Like all parts of mathematics, calculus requires clear, dependable definitions, right? I think we can't do much without good definitions. And we thought we clarified the definition of limit of a function at some point, and we also tried to rigorously define it. So first we defined it so that we understand it. We also looked at paradoxes. We looked at Zeno's paradox, and we provided a perspective that kind of removes paradox in Zeno's paradox, right? We saw that, how Achilles could catch up with the turtle or the tortoise, and how we can argue about an infinite process without really having to go through the infinite steps. This is really important. And then we went, of course, to epsilon delta definition. I hope that you were able to look at least some of what happened last time. It's okay if you were not able to do that. The discussions, the video recordings are going to remain there. But I urge you to take a look at it And if there are any questions, please feel free to ask now or whenever you can. With that, I think what we are going to do in today's discussion, just for the sake of some structure, is that we are going to work out an example of how a rigorous definition can be applied to a simple example. Maybe later on we will take a slightly more complicated example and again show the same thing. It's important for us not to leave difficult exercises for readers or audience of this discussion. We should all, try to solve various problems. And so we'll start small, and then we will go on to the discussion of some of the more historical um, ponderings, if you will, how some of our forefathers started thinking about intriguing issues. So first, I think Apurva will go ahead and take an example and show us how we can be rigorous about limits. So I think Apurva, I'll give
Okay.
it to you.
I'll share my screen.
Cool. All right. Go ahead.
Once again.
Yeah.
Okay. Okay. Can everybody see the presentation?
I
Yes.
can't see it yet. Let me stop. Yep. Are you
Okay.
sharing?
Yeah, I'm sharing my screen.
Can anyone confirm?
Yeah, I can see the screen.
Oh, okay, cool.
Okay. Can you see it now? Yet?
I'll try to look into what my problem is, but why don't you go ahead?
Okay. So, um, yeah. So last time we talked about the epsilon delta definition of a limit, and um, well, it wasn't a very easy concept to grasp, as it's not calculus. But we we took we took this formal definition of epsilon delta, and we kind of we put it into words that would make it slightly easier to understand. So this is not very easy to understand still, but we'll make it easier to understand. So right, so last time we figured out we can say that um, the limit as x tends to a exists and is equal to L if for every positive distance epsilon from L, there's a positive distance delta from A such that if x is closer than delta to A but unequal to A, then f of x is closer than epsilon to L. So this again, this is a large sentence. It's a long sentence. It may not um, be very easy to understand initially, but we can split that into parts again, as we saw from the last time. So, first we can say that we know that we're trying to show that the limit as x tends to a exists and is out. We know that's what we're trying to show. And then we need to define two positive values. Okay, for the first positive value is epsilon, right, which is defined, and the um, second value is delta. Now we have to choose delta so that this next statement is true. So if x is between a plus delta and a minus delta, and f of x is between L plus epsilon and L minus epsilon, and x doesn't equal a. then the limit exists and is equal to L. So if we can choose a delta to make this uh, statement, if we can choose a delta to make that true, then we can say that the limit exists. And the hard part, once you figure out how to prove everything and all that, the hard part, which we'll come back to that, is why this statement can be used to prove is to say that a limit exists. Now we said, right, that, oh, this is the epsilon delta definition, right? So if we prove this, then the limit exists. But why can we say that the epsilon delta? Why does it hold, basically? Why can we say that by saying this statement right here, right? Why does the limit as x tends to a equal L? That's that's the tougher question. But you can. It's hard to think about it unless you've understood epsilon delta limits. So to help you better understand epsilon delta, I'll show an example. So suppose we are trying to prove this limit, that limit um, of 3x minus 7 as x tends to 4 is equal to 5. So basically the function f of x we have as 3x minus 7. And we're trying to find the limit of this function as in x, the input, tends to 4. And we want to prove that this limit is equal to 5. Now if you plot in a graphing calculator or use the limit laws, you can see that um, it approaches as 3x minus 7 as the for the function 3x minus 7 as it approaches 4, as x the input approaches 4, this value approaches 5. And but we're just saying that, we're saying that qualitatively, we don't have a precise definition. Now uh we can't say for sure that it does. All we know is it seems to approach it, but we can use our knowledge of epsilon delta limits to prove that this limit is true. So if we're trying to prove this, okay, we need to show that if 0 is less than as the value of x minus is less than delta, is what we that's what we saw before. Okay, we need to assume this, right? uh the first step is assuming this, and this is just a general form. How would we adapt this inequality to be specific to our example? Can we say that, how would we rewrite this inequality so that it is specific to our example? Now we know the general form of a limit is limit as x or it tends to a, or the general form of a limit in this case, right, is limit as x tends to a of f of x is equal to L. So if you can replace that into, if you can take the values from this limit that we're trying to prove and replace those values into the this general form we have, then we can get the specific form of our 0 less than as the value of x minus a is less than delta. We can get the um, uh, uh, specific form of that statement. So if we can see that a is 4 because the general form limit as x tends to a, right? So in this case, x is tending to 4, so a would be 4, and we can just rewrite this as 0 is less than mod x minus 4 is less than delta. So now that we have this assumption, now we need to show that if our previous assumption about delta, this assumption about delta, if we uh, um, now we need to show that if this is correct, then um, mod f of x minus L is less than epsilon. So again, how would we modify this general form to for our specific um, for this specific situation?
So f of x would be 3x minus 7, right?
Yeah, so f of x is 3x minus 7 in this case, and L would be
5, I
5.
think.
So our specific form would be this: mod 3x minus 7 minus 5 is less than epsilon. Basically, what we're trying to show is that um, as that if our previous assumption, right, x is closer than delta to 4, we want to show if that holds, then 3x minus 7 is closer to 5 than epsilon. So 3x minus 7 is closer than epsilon to 5. So um, does everybody get that? Everybody got that? Okay. Um, I hope so. And we'll go on to the next one. Okay. Now, if we remember the steps, there are some steps to um, actually prove that this limit is true. We've So if we show that this holds, now we still have to show it. We've established our basis, but we still need to show that the limit of 3x minus 7 as x tends to 4 is 5. We still need to show that we still need to show that through 3x minus 7 mod 3x minus 7 minus 5 is less than epsilon. So let's start with the proof now so that we can show that. So what will be our first step? This now the step before everything that we first need to establish. What will be the very first step? Now I can um, go back to our this slide or this slide. Okay, this slide might be better. Okay, what is the first step to um, prove our specific limit?
Prove that it exists.
We want to. Sorry, I couldn't hear you.
Prove that the limit exists.
Yeah, so that's what we want to do. But to prove that, now we're starting with the proof. So to prove, what would be the first step in the proof? That's correct. The first step is to note that what we're trying to prove. But in the proof itself, what would be the first step? Well, the first step, right, in the proof would obviously, this is the very basic step, but it needs to be said. Okay, otherwise it's not rigorous. So first we need to say that epsilon has to be, we need to define epsilon. It has to be greater than 0. Okay, now that we have epsilon, what's the next step?
Say that delta is also greater than 0, I think.
Okay. We can, yeah, but specifically, we have to choose our delta. Okay. Now, this, in, um, in this case, we are going to choose delta as epsilon by 3. Okay, in this specific case. And for now, we'll just say this, and the reason why we're choosing delta as epsilon by 3, it'll be clear soon. But what will be the next step now? Now we get to the important part. What's the next step? We have defined epsilon, we've defined delta. Now what will we do?
Now do we like input into the two equations and solve them and see if they turn out to be true statements?
Okay, so like we said on our previous slide, we there's one specific statement we assume, right? So we need to start with that assumption, right?
Yeah. Like, do we have to substitute in the values?
Yeah, we should substitute in the values.
Okay.
Um, so third thing is we have to assume. Okay, uh, this inequality um, we laid out in the previous slide. So this is an important step, because from here we have will this is the beginning. This is once we assume this, we can start proving that the next step. Now, okay, what will be the next step then?
So I just want to point out something for the for the some kind of aid. The basic point here is really the language of logic. There is something called as conditional or implication in mathematical logic, and this definition kind of revolves around it. So I think if you guys are new to mathematical logic, then this will be slightly challenging. So when we say if P then Q, if some statement then some other statement, what does that really mean? This definition uses a lot of that. So when we say that we assume that x minus 4, the, the absolute value of that is less than delta, that's our definition. That means if we are given that, then we have to show that the definition, the value of the limit is less than epsilon, it's close to 5. That's what we want to do. So when we say if, then we assume that thing to be true because that's given to us. So that's why I think the step is 0 is less than mod of x minus 4 is less than delta, because we are not allowing x to deviate from 4 more than delta. That's what that means.
That's exactly, yeah. We want to make sure that x is within delta of 4. And yeah, we need to, so we assume this, okay? And so once we assume this, we need to prove this, right? That f of x, or really in this case 3x minus 7 minus 5, mod of that is less than epsilon. So that basically we want to prove that 3x minus 7 is less than epsilon away from 5, assuming x is less than delta away from 4. Okay. Now, let us start, okay, by simplifying this previous expression, okay, this expression that we have relating 3x minus 7 and 5. Okay, let's start by simplifying it. Okay, we have, yeah, this is, we just remove the parentheses, simplify it. Now, okay, let's go through this proof. Now I want you guys to tell me the next steps slowly, as one by one, as we'll go through this proof together.
Now we
So
take
what's
out
the
the
next step?
we take out the absolute value bars, right? Are you gonna simplify this
Okay.
expression even more now?
Now, yeah, you can. We basically we want to simplify. We want to simplify this 3x minus 12 expression even further.
Okay. Then take out the absolute value bars by like saying that
Okay.
minus epsilon is less than 3x minus 12, which is less than epsilon.
Okay. Where does epsilon come into here right now?
Because it says that absolute value of 3x minus 7 minus 5 is less than epsilon, right? So, and
That's what
We,
we're
we need to
trying to
prove
prove.
that, right?
We need to prove that. Yeah.
See, what we have at our disposal is delta.
Yeah. We
Okay.
only have delta. So just a simple way, just some way to simplify this further.
Yeah, maybe you can show the step, Apurva, so that people can relate
Okay.
to it.
So yeah, that's a good idea. So it's a simple step. Our next step is to do just remove the 3. We remove 3 from the x minus 4, and we know that now the x minus 4. Um, so it's just we just we just factor out the 3 from both the 3x and 12 and then remove it from absolute value. We can do that because first we have to make it mod 3 times mod x minus 4. But since mod 3 is 3, we just say 3 mod x minus 4. 3 into mod x minus 4. So after that, we see this x minus 4, right? It's familiar. We can do something with that x minus 4, right? What can we do with that x minus 4? Yeah, go ahead.
So like x minus 4, we see that the other equation that like x minus 4 is greater than 0 and less than delta, right? And we've said
No, x minus 4 is,
yeah, is greater than 0 and less than delta.
yeah, less than delta. Yeah, okay, go ahead.
And we've also said that delta is epsilon by 3. So like if we
Uh-huh.
put
Okay, you're doing it correctly. Yeah, go slow. First, what do we do with the x minus 4? We should replace it by delta, is what you're saying, right?
yeah,
Okay, but it's less than delta, so we also have to change the sign, right? Good job. Yeah.
So
So we say that
look
it's
at how
less
the
than.
equation changes into an inequation. So basically, since mod of
Yeah.
x minus 4 is less than delta, the left-hand side has to be less than 3 times delta.
Yeah. So since it's 3, so 3 is, so it's simple. If 3 times a, right? If you have 3 times a and a is less than b, then 3 times a is less than 3 times b. Um, so 3 times mod x minus 4 will be less than 3 times delta because mod x minus 4 is less than delta. Great. Now, Shashwat, you said the next step too. What will be
yeah.
the next
So
step?
the next step is like we can instead of delta we can substitute it with epsilon by 3 because we've shown that delta is epsilon by 3, right? And then we can cross cancel and it just shows that it just equals epsilon. So
So
Yeah.
what do we have?
So I think, Apurva, you have two equal to signs. Instead of that, I think we still need to retain the less than sign there.
yeah,
Well, those equal to signs just mean it's equal to the above, the above.
Right. But I think the way the equation works, like mod of 3x minus 12 must be less than 3 times epsilon by 3, which means that
yeah.
it must be less than 3. So, delta is epsilon by 3, exactly. But I think in the equation, you should still retain the less than sign.
Okay, that's
Yeah.
that's fine. Then
Now
if
we've
we
like
put it side by side, then yeah.
so now we've like proven that like the 3x minus 7 minus 5 is less than epsilon, right? Basically.
Right.
Yeah, so we can we have this now. Mod of 3x minus 7 minus 5 is less than epsilon. Yay, we proved it. Now, because of the epsilon delta definition, because of this definition that we have, okay, now we can say that this limit is correct. Okay, we can say that this limit exists and is equal to 5. So we've proved it, yeah, using the epsilon delta definition of limits. But now we know that this is a definition, right? The epsilon delta definition, right? Can we reason about that definition? Can we? It's a little tough, but we all have to see like by ourselves. Is that how can we how can we convince ourselves that the epsilon delta limit works? So like I said before, why does saying this statement on the right, mod of 3x minus 7 minus 5 is less than epsilon, why does saying that prove that limit of 3x minus 7 as x tends to 4 is equal to 5? Why can we say that? Now the easiest thing you can say is just, oh, epsilon delta definition. It's because of the epsilon delta definition. It's a definition, so we can say this. Yeah, it's a definition, so we can say this. That's correct. You can use that, but I mean, it gives some deeper understanding if you understand why. Why can we say that? Why does the epsilon delta definition hold? So if anybody has an answer to that just yeah, go ahead and say it. Otherwise, it's a good question. It's something that might require a bit of thinking. So
Wait, I have a question in the this thing.
Uh-huh.
So over here in like the first thing we say delta is equal to epsilon over 3, but then like in the algebra steps like below, we see that epsilon is less than 3 times delta, which means delta is greater than epsilon over 3, which is like not the same as the thing that we had said before.
Epsilon is less than 3 times delta. How come?
Oh, it's like so like by the end of it we say epsilon is equal to epsilon, right? The 3x minus 7 minus 5 absolute value. And so like in that like third step we say that 3x minus 7 minus 5 absolute value is less than 3 times delta. And so since that's epsilon, then how is that less than 3 times delta?
Well,
So there, I think if the mod of x. Sorry, go ahead, Apurva.
I think the mod rules don't really come into play here too much. But what happened is we remember 3x minus 7 minus 5 mod of that is less than epsilon. This is just algebra, but we have to keep in mind that this, right, 3x minus 7 minus 5 is less than epsilon, not equal to epsilon. So if we pull this down, we can just replace this with epsilon.
I think his question is how come we did so Ashwin, let me understand. So 3 mod of x minus 4 is less than 3 delta. Are you do you agree with that?
Yeah.
Right. So 3 times mod of x minus 4 has to be less than 3 times delta because mod of x minus 4 is less than delta.
Yeah.
And then we know that, we have the choice, we have the freedom. We have the freedom to say that delta is epsilon by 3, which means that 3 times mod of x minus 4, which is same as our, the difference between, 3x minus 7 minus 5 mod is the same, is less than 3 times epsilon by 3, because delta is just same as epsilon by 3.
Yeah, okay.
So I
Now,
think maybe the confusion is because of those two equals. Apuru, can you just change it so that we can visibly make it more appealing instead of those equal to just put those as less than?
okay, 1 second. Okay. Can you guys see it now?
Yeah.
Okay.
You agree with that, Ashwin, now?
Wait, I can't see any screen sharing. Yeah.
Oh, sorry. My bad. Okay. You see that now? Okay. I changed it to less than. My bad.
Yeah, yeah.
Okay. Does that make it better? Did you resolve your confusion, or is there anything else that you wanted
Yeah,
to say?
yeah, I
Maybe I
got
didn't
it.
answer your question correctly.
I got it. I
Okay.
got it.
Okay.
Um,
Sorry
Cool.
for the
So
confusion. That was a good suggestion.
I have a question.
go ahead.
So how did you choose what delta should be? Like how did you choose epsilon by 3?
Well, that is a really good question. That is exactly what I had trouble on when I learned epsilon delta. So now we can do a ton of these. Like now, much of this is just algebra. The hard part is choosing what would delta be. Now, I can go over some other examples if that would help. Choose delta, but this time you guys are going to choose delta. Is that all right? Because I hope everybody has gotten the algebra part of it. But I mean, I think all of us know algebra, right? So I think you guys have gotten the algebra part of it. But uh, now choosing delta is the hard part. So would it be better if we go over some more examples and you guys choose delta?
Yeah, I think that would help.
Okay. Then why don't I share this whiteboard that I have? 1 second. One second. Let me just. Okay. Can you guys see this? Can you guys?
I can see it.
Yeah,
Okay.
I can.
Great. Okay, great. Now let's start with another problem. Okay. Uh, should I make the font? I'll make the font a little bigger. Okay. Um, let me see. So our goal is to prove limit. Now I'll write the limit and everything with my pencil, but this part I'm just gonna write with this. So we want to prove that limit of this function. I'm gonna choose this as f of x. Okay. Uh, 5x by 3. Actually, let's start with an easier one. 5x. Okay, 5x plus 2 maybe. Okay. Now, if we plot this on a graphing calculator, maybe you guys should just do this by yourselves. Now let's say we want to find the limit. Okay, limit limit as x tends to some 3, let's say. Okay. Now, what would the limit be? What would the function tend to? Do you guys think? Maybe we'll plot it on a graphing calculator and see. Okay. And if you go to x equal to 3,
17. 17.
Yeah, so it does seem to tend to 17, right? But again, I say seems to tend to 17 because we don't know. So why don't we do that? Let me add x to 3. Seems to be 17. Okay. Now, first thing we do, we set up our basis. Okay. Now, what would be our basis for this? Anybody? Basis are two inequalities that we need. One we're gonna assume,
0,
and one we need to prove.
0 is less than absolute value of x minus 3,
3
which is less
and
than delta.
our first one, and
The second one
our
is
second one.
0 is less than. Oh, sorry, not 0. Sorry. I was thinking of the one before. Absolute value of 5x plus 2. Minus
Let me
7.
just put this in for, minus 7.
17.
Minus 7?
I thought
17.
7.
Sorry, I heard 7. My bad. Yeah, and
Less than epsilon.
perfect. Those are our two initial things. Okay. Now, where did I do this?
I think I have an idea of what we can choose for epsilon.
Okay.
Could
So first thing is let epsilon greater than. I'm just gonna say e. Okay, I put epsilon again. Remember last time we did d and e. I'm just gonna do d and e again. Okay, d and e, not d and e.
I think
Okay.
I have an idea of what we can choose to be like delta.
Okay, then let's write that down. Give me a second. Choose d.
I think it should be like epsilon by 5.
You put the e by 5, epsilon by 5. Perfect. That's an interesting answer. Okay, let's see. Why don't we just write that down? Okay. Now you guys walk me through the proof.
So now we can simplify the second inequality, right? The one that has 5x plus 2 minus 17. The absolute value of it is less than epsilon.
Okay.
So the simplified version would be 5x minus 15 plus 2. Yeah.
Minus 15.
No, minus 17. It'd be minus
Minus
17.
17. And my bad. Okay. And we can simplify that too.
Equals 5x minus 15.
Okay, 5x minus 15. Next.
Yeah. And then that would equal absolute value of 3 times x minus 3. Absolute value of x minus 3, right?
Say it again.
3 times absolute value of x minus 3. Oh, sorry, 5 times absolute value of x minus 3.
Good job. 5 times absolute value of x minus 3. Okay.
Right.
And
Which
now I believe we all got the algebra, so you can skip a few steps here. Don't go too fast, but you can. Sorry, my bad. Go ahead. Next.
so less than 5 times delta, right?
Okay. Now, yeah, mod of x minus 3 is less than delta. So, great,
5
we can say that. Okay. And if you need me to switch between the two tabs, it's very easy. Just say switch or, anything, and I'll switch. Less than 5
times delta.
5 delta. Okay.
Right. Which since
And
we've said that delta equals epsilon by 5, right? So so we said so that equals 5 times epsilon by 5, which
Okay.
equals epsilon, which is less than epsilon.
So we proved our statement. This one, right? This one is what we were trying to prove, right? And we proved that, right? So um so by the epsilon delta definition, uh this limit is proved. Great. You want another one, or do you think you got it, or I'll give it another one. Okay, let's go. One more. Okay. Um. Again, 5. Let's see. 7 by 3. So 7x by 3. Okay. 7x by 3. Okay. 7x by 3. Okay. Yeah. I'm gonna do plus 9,024. Okay. Plus 9,024 is equal to, now let's just again write the limit. Okay. Limit as x tends to 5, let's say. Okay. Now you might not want to check this on the graphing calculator. You'll have to go all the way to, I just, okay, but I said 9,024. I just wanted to make sure. I wanted to ask you, what is the point of this plus 9024? This term, okay, this degree of this term with degree 0, right? This constant term. What is the point of it? Is it a part in choosing delta? First of all.
It helps us while choosing epsilon. With the algebra, when we find
Ah,
something common, in that part it helps out. So we can figure out what to
right.
take as epsilon as compared to delta.
Yeah. So basically, it comes in the proof, but it does specifically delta. Um does it play a role in choosing delta?
We have to like use that equation, right? And like add 9,024 to see like what it seems to approach.
So that's true. Now, suppose we get what it seems to approach and all. The reason I'm asking this is because 9024 is a complicated number. You have to go on the graph, check, put this plus 9024, and then check what it approaches. So rather than that, I'm just wondering. Now, since we're trying to find ways to choose delta, does it make a difference when choosing delta specifically? Now, in this step, okay, choosing delta, okay. Now, in this, sorry, not this step. What am I doing?
Well,
This step. Does it play a role? Yeah, go ahead. Sorry.
so I think what I did like I just found ways to factor like numbers out from the equation, because like, and then I just divided epsilon by that so it would like cancel out and give epsilon. That's basically how I
So
found it.
canceling out is an interesting thing. Now, I don't. Okay, I'm gonna change this 9024 to something smaller, 3. Okay, or 2, even better. Now, this is something easier to let's do this whole proof one more time. Okay, let's try to prove this limit. But first of all, we need to find the limit. What does it seem to tend to on the graphing calculator?
Forty-one by 6.
41 by 6.
Wait. No. I think no, it's 41 by 3. Yeah, 41 by 3. I'm doing it in my head.
40,
Let me technology.
Actually,
Yeah, it's 41 by 3, right?
yeah.
Yeah.
Yeah, 41 by 3. Good job. That's the best. Yeah, fractions are always, better. So good. Okay, now we're to bases. First, the one with delta.
0 is less than absolute value of x minus 5, which is less than delta.
Okay, and our next one.
7x plus absolute value of 7x plus 3, or 7x by 3 minus
Okay.
plus 2 minus 41 by 3
Okay.
is epsilon.
Less than epsilon. Okay. Now this is our thing. Okay. Okay. Let's go into the proof. First thing. We have epsilon. Okay. Let epsilon greater than 0. First thing in the proof. First thing. Now what the next step? Choosing delta. Let's choose a delta. Okay, what's the delta?
Is it 3/7 epsilon?
3/7 epsilon. Okay, let's try that. 3 epsilon over 7. Is there anybody with a different value of delta maybe? Or does everybody agree with that? Does everybody think the same thing, or maybe there might be a different one? Okay. I think everybody agrees with it then. So why don't we choose it as 3 epsilon by 7? Okay. Now again, walk me through it. I'm not gonna do it now. Let me just list this one. 7x by 3 plus 2. This is sorry. 7x by 3 plus 2 minus 41 by 3, right? Is equal to, simplify
That
this.
equals 7x by 3 minus 35 by 3. Absolute value of 7x.
Okay. I didn't hear you.
It's 7x,
Please.
the absolute value of 7x by 3 minus 35 by 3.
Minus 35 by 3. Okay.
Right, and now we can factor out the 7 over 3. Factor out.
Wow, that was a good one. Good point factoring out 7 over good thing that you factor out 7 over 3 and not 1 over 3. So good. So and what would be left in the inside?
That would be x minus 5. X minus 5.
X minus 5.
Right, which would just equal 7 by 3 times, which would be less than 7 by 3 times 3.
7, which would be less than 7, since that is less than delta, 7 delta by 3. And again, let's.
Then it just cancels on stuff.
Then that is very simple, right? And then what did we choose as our delta? We chose it as 3 epsilon by 7, right? So 7. Let me just write it down. I'll make it easier. 3 epsilon by 7, right? Divided by 3. Sorry. Let me just remove this box. I hope I can remove this box. Okay. Sorry, it's coming in. And then that's epsilon. So it's a good one. Now so we proved this one, this limit again. So I want to know, okay, how did you guys choose 3 epsilon by 7? Okay, for delta, did 2 come into play anywhere there while choosing 3 epsilon by 7? How will you guys? Uh, does it play a role? This plus two, would it make a difference in the? Basically, I'm asking. Okay,
No,
would
not
it make
really.
a difference in? Huh? Sorry.
No, it doesn't really make a difference
Like,
because
so if I put 7x by 3 plus 9024, what would be your delta?
so that would just be 7x by the delta would
So,
be
so, so-
the delta would
sorry, I
also
mean,
the delta would
uh,
still be at 3e by 7.
3 epsilon by 7. Perfect. Yeah. So it doesn't play a, um, doesn't play a role in determining, uh, doesn't play a role in determining delta, does it?
No.
Okay. So that's, so that's a, now, okay, I might giving a, okay, I'm gonna give a little more challenging one. Okay, let's see about this one. Okay, let me first write the limit. Limit as x tends to 2 of okay, let's see, 2x do this. Okay, but this one now, first of all, let's find the limit. Okay, let's find the limit, and that must not be very hard. Okay, the
Limit
graphing
is 10.
calculator.
Limit
Limit is
it seems to be 10.
okay. That's good, a good answer, and that's a good limit. How by the way, how did you find that limit? Did you put it in a graphing calculator or not? Did you just plug 2 in into the?
I didn't really need a graphing calculator. I don't even have one anyways, so I just did it in my mind.
I mean, you can use Desmos online graphing calculator, but okay. Now,
I think people
what you're
use their
saying,
intuition.
yeah, yeah, intuition is good here, um, and it turns out it really, for the type of function I've shown right now, it doesn't matter whether it's, um, I mean, you can just really just plug it into the equation and get the limit, because
I
now,
think the point of this exercise, I'm sorry to interject, Apurva, but I'm just saying that the point of this exercise is really epsilon delta limits are an exercise in inequalities. It's like if we are better at algebra, then we can, or we understand algebra a little bit better, then we kind of develop the insight here. Although different functions can pose different problems, we only have tried with simple polynomial functions here. And there, whatever tricks that we have done perhaps have worked, but it might get a little more trickier as we look at different functions.
Mhm. Yeah. Um, okay. So I'm gonna just why don't this will be the last one we do. Okay, and
I think you
I
should
believe you
give that
guys.
as a home exercise.
Okay, why don't you, yeah, why don't you guys uh um do the proof by yourself, and we will discuss it next time then. And I'll send this limit on the WhatsApp group. Okay, that's a
Sounds
good
good.
idea. But does everybody get the general idea of choosing delta now?
Yep.
Yeah. Okay.
Some idea, yes.
Um,
Yeah, so I think, again, practice makes us better. We should just try to, you know, I like to say this, that we have now found a hammer, and maybe we should try to use it judiciously, so that we make some progress. I think that's the general idea here. I hope, this kind of hands-on thing was actually useful. Um, it's kind of difficult to do this on online meetings, but I think we did it reasonably well. So that's good. So yeah, it's almost 1 hour. We perhaps are at the end of this discussion, but I just wanted to leave you with one important observation. And so, is that okay, Apuru, if I shared my screen?
Yeah, let me just stop sharing. Sorry.
No problem. So we are just perhaps going to talk for 5 more minutes, if that is okay with you guys. I think we should do that. Can you guys see my screen?
Um, no, it's fully. Yeah, we can see it now, or I can
Okay,
see it
cool.
now at least.
All right, so I'm just going to draw your attention for last 5 minutes, and sorry for running over. But I think we started about 8:35, so I think we're about just 1 hour, and I'm going to take 5 more minutes. This is an intriguing historical problem. Let me start with a simple question. What is this?
Like the most basic function of a parabola.
Okay, it's an equation. Is that what you said?
Yeah, it's an equation, I guess.
Okay. Any other answer? What is this?
Really, a function, right?
It's a function. So y is a function of x, specifically x squared. Okay. Does that also mean something else to you guys? Feel free. It's just an exploration. It's a
I mean,
decidedly open-ended question, for example.
I'm thinking of parabolas when I think of this equation.
So yeah, so Shashwat thinks that it is parabola. So yeah, cool. So I think it's something like this. This is an equation of a parabola. But you guys are ahead of your time, right? I mean, or ahead of others. So I just want to kind of draw your attention to the fact that these two things are perhaps the same. This is same as that. We're all in the 21st century, right? And here, a parabola and y equal to x squared. These are two synonymous things, right? But it was not always the case, right? People had to invent different tools in order to make sure that y equal to x squared kind of triggers a parabola in your mind. It was not always the case. We have got to be sensitive to this fact that now what is obvious to us was not always the case. Like, I mean, you guys know that, okay, we know the coordinate system, we know y equal to x is the equation of a straight line, we know y equal to x squared is a parabola, but it was not always the case. And I want you to kind of, appreciate this, that this, I'm talking about something that happened 500 years ago. Um, Francois Viet was the name of the mathematician who said that, okay, we can use algebraic equations to show some geometric figures. And then came along this mathematician. Do you Can you guess who this is? Perhaps you don't know. That's okay. His name is Pierre de Fermat. Now, what this guy did was, something very simple. Let me try to draw again your attention to this particular problem that he tried to solve. Here is the problem that I have got a segment AB, its length is A. Imagine that segment to be like a piece of wire whose length is A. And I have got two such wires, and I want to bend this wire so that the area enclosed by that wire is maximum. Is that thing clear? That I want to bend this, so I'll bend it at some P, right? And I want to bend it such that whatever enclosed rectangle that gets created, it has got the maximum area. Can you give me if the problem is clear to you, then can you tell me the equivalent in numbers, for example?
I don't really know like the equivalent numbers, but like I've done problems like this where you have to like this is like the AB is the perimeter, right? And you have to like find the vertex of whatever equation you use to solve the area, the maximum or minimum.
Right. So you're saying that, okay, if the perimeter is fixed, then what is the shape of the rectangle that makes its area the maximum, right?
I
And
I think it's a square because there was one problem that we did. I'm not sure if I'm right, but there was one problem that we did where there was something like this, and we use maxima minima to calculate at what value of x we would get the maximum area.
Right. But again, I want you to be insensitive to this fact that this has happened 500 years ago. So we have to go back and sort of unlearn some of the things that we now know, right? So you guys are absolutely right that this is like you have a barbed wire, just you can imagine a barbed wire which is length A, and now you want to enclose a rectangular area, and you want to enclose the maximum possible with that same barbed wire, one single barbed wire whose length is fixed. And now we know that when it is a square, that is when the area enclosed is maximum. But these guys did not know this, right? And a number equivalent of this is like, you have two numbers, their sum is fixed. Now how do you split that sum in two numbers such that the product of those two numbers is maximum? For example, if the number is 10, how will you have the sum of those two numbers is 10, but their product is maximum, right? When will that happen? Like you perhaps simple calculation or some simple calculations will tell you that 25 is the maximum, and it will happen when x is equal to 5, which is half of the sum. But we have got to prove that it is maximum, because there are infinite sums that we will have to, infinite products that we will have to find, and then maybe we will be able to guess that, okay, it happens when one of the numbers is half of the sum, or when the sum numbers are the same. But what Fermat did was something very interesting. He did many interesting things. One of them is this, that he said that I'm not going to look at that value of the product, which is maximum, but he did something else. He said that I'm going to look at that area, that particular division. I'm going to bend it such that it is smaller than the maximum. So if let's say that, at some point when we bend it as a square, let's say when, we know that it is x is equal to when it is a by 2, when that is when we get the maximum area. But what he said was let me think about it like this, that I am going to have the bend such that the area is not maximum. So it is a rectangle. In this case, let's say if I bend it at x, then we will have something like this, right? We will have an area with, the length of it is x and the other side is a minus x. But I'm going to turn it around and say that, okay, it is, x plus e and a minus x plus e. So why is he trying to do this? Because we know that the rectangle, when you turn it around, it would be the same. So basically x and a minus x, the area of x and a minus x will be the same as the area of x plus e and a minus x plus e. Is this clear? I'm just saying that I don't want to find the rectangle with maximum area. But if the rectangle is smaller than the maximum area, then there have to be two rectangles which are of the same area. One of them is x and a minus x. The other is x plus e and a. There have to be two rectangles because you turn them around and they're the same rectangle. I mean, the area of those two rectangles is the same. So what he did was something like this. The area of this rectangle, x and a minus x, has to be the same as x plus e times a minus x plus e. Is that understandable? There have to be two rectangles who have the same area. And since it is not maximum, you can turn it around by 90 degrees and it is the same area. And that's why x times a minus x has to be x plus e times a minus x plus e. And if you simplify, you get a times e minus 2x e minus e squared. And again, you can take e common here and you say that for this product to be 0, you need to have either e is equal to 0 or a minus 2x minus e to be 0. Now, if a minus 2x minus e to be 0, then what does that mean? A minus 2x minus e, if you want to make it to be 0, then a minus 2x minus e is equal to 0. And for this particular thing, for this particular thing to be maximum, e has to be 0, which means that a is equal to 2 times x. And which means that x is equal to a by 2. So when x is equal to a by 2, he somehow found this method which seems spooky, right? I mean, it's not still very clear, but if you think about it, and I want to leave you with this thought that, do you agree with the way Fermat did it? I think it's a very ingenious way of doing things, and I want to leave you with that. We're already at 9:50. But like Arav said, that okay, we can use maxima, minima, we can do derivatives, once we know calculus. But these guys are trying to invent calculus, and I want you to see their pain. They're struggling just like we were struggling a few minutes ago with epsilon delta a little bit. So this struggle is the natural part and the natural component of trying to learn something new. So Fermat invented something that could provide us a way of trying to find the maximum value of some functions. And he did that by taking an algebraic view of it. Like, here it is all algebra, right? We're kind of detached from geometry. We just want to find out a value of E, which will be 0 for the maximization. And it will happen because of a relationship between x and a. In this case, it happens to be a by 2. I'm going to leave you guys with this, but this is what it is that, the struggle is fine. And, we, I think it's just an example of where the creativity comes from. Try to look at this particular argument. Maybe we can discuss it next time. But till then, that's it. I think, sorry, we went over a little bit, but I hope that it was worth.
Yeah, it was
Cool.
great. Thanks. Also, think about the why. Why does epsilon delta definition work? Think about that too.
Cool.
That's another thing. And yeah. All right.
All right. We will discuss it more on, if you have any questions, again, as usual, ask them on the group. All right. Thank you, guys. Sorry for the delay, Asim. I think, but I hope
Yeah.
it was all right.
No, it's not an issue.
Talk to you soon.
Sorry.
Bye.